So in this video, I want to talk to you about a graphic, quadratic, and the standard form. And the standard form of a quadratic is just what we call ax squared plus bx plus c. And actually, let's set this equal to y, or f of x. Let's write it f of x. So this is f of x equals ax squared plus bx plus c. So it's a function of x. And when we graph a quadratic, we get the familiar shape, which is the parabola, or you may see it as the U shape. It looks something like this. And this parabola has key features that we're going to look at and identify. In particular, when we tend to graph ours, we're going to graph them that may look something like this. So there's certain things we want to identify on this. In particular, we want to be able to identify this value right here, which is called the vertex, which generally occurs in function form at negative b over 2a, and evaluating the function at f of negative b over 2a. So that means whatever you get for that, whatever you get for this x value, you plug it back in, and you're going to get your y value at the vertex. Then you have your x-intercepts, and generally speaking, you're going to have two x-intercepts. But the x-intercept is where it crosses the x-axis. So these are x-intercepts. And you also have your y-intercept. Well, your y-intercept tends to be, right now mine is on the vertex. So if it's not on the vertex, this would also be a y-intercept. It's where it's crossing the y-axis. And then you also have what's called the axis of symmetry, which splits the parabola in half. So we're going to be able to identify all of those things. And it's very easy to identify from the graph, but we're going to do it from the equation now. So we're going to do it from the equation. And it all centers on finding the vertex. And so remember, the vertex is just, the vertex of this is found by finding the x-coordinate first. So you have a x and y pair at the vertex. The vertex is some xy coordinate where the x value, x is equal to negative b over 2a. So in this equation, notice you have ax squared plus bx plus c. If we can identify a, b, and c, then we can use this equation to find the x value. And then once we have the x value, to find your y value, you're just going to evaluate the function at whatever you got for that negative b over 2a. All right, so let's go ahead and try to find this. And once you have that, the axis of symmetry, this value right here for x is also your axis of symmetry. And then we can find our x and y intercepts. The x-intercept, the value will always have a x-coordinate and a 0 for y. We can take advantage of the fact that you get a 0 value for y. So that means when you're solving this equation, and well, if f of x is y, you can plug in 0. And generally what you're going to do is factor this to get those values. And then the other thing that you're going to look for the y-intercept, at the y-intercept, you get a value of 0 y, so your x-coordinate is y. So you just set the x's in the equation equal to 0, and you'll find that. So let's walk through the example that you gave me in my math lab, and we'll try to answer those questions. Right? So we have this equation which says f of x is equal to x squared minus 6x plus minus 7. And so the first thing I want to do is I want to find, they asked how does the graph open, up or down? Well, first we want to identify a, b, and c. And here your a is equal to the number in front of x squared. So no numbers in front of x squared, so it's understood to be a 1 there. So we have a equals 1. B is equal to the number in front of x, which is negative 6. And c is equal to the back number, which is negative 7. So there's a, b, and c. To tell how the graph opens, a positive a value always opens up. A negative a value always opens down. So in this case, my a is 1, so we know the graph has to open up. To find the vertex, the first thing we're going to do is going to find the x-coordinate of the vertex. So all I do is I use the function x is equal to negative b, so that's a negative 6, over 2 times a, which is 1. So negative times the negative is positive, so that's 6 over 2. 6 over 2 is just 3. So the x-coordinate at the vertex is 3. To find the y-coordinate, we go in and we evaluate this equation right here. We evaluate this equation when x equals 3. So I'm going to evaluate f of 3. That's what this means. That's 3 squared minus 6 times 3 minus 7. 3 squared is just 9. Negative 6 times 3 is a negative 18 minus 7. right? So 9 minus 18 is negative 9, minus 7 is equal to a negative 16. So this value is just 3 negative 16. If I know that, then I can get the axis of symmetry, because the axis of symmetry occurs at whatever the x coordinate is at the vertex. So the axis of symmetry is just occurring at x equals 3. And the axis is always an imaginary line, but it's always a line. So we always write it as x equals something, x equals 3. And if I want my x and y intercepts, or my x-intercepts, to get those, I have to factor this. Because what you're going to do to find the x-intercepts, at the x-intercept, you're going to let y equal 0. In this case, this is f of x equals 0. So I'm going to say x squared minus 6x minus 7 is equal to 0. I need to factor this. In order to factor this, I want to know what numbers multiply to negative 7 but add to negative 6. Well, they are 7 and 1. And so I get x minus 7 times x plus 1. These are going to be the factors of that equation. These are the factors of that equation, right? And so what I'm saying is that when it's factored, these are equal to 0. So what I'm telling you is that when you multiply these two things right here, this x minus 7 times x plus 1 has to equal 0. In order for that to be true, then, anytime you multiply a number by something, you get a 0 value. One of these numbers have to be 0. So we just set them both equal to 0 and solve them. So I get x minus 7 is equal to 0, or x plus 1 equals 0. Changing the signs, I get x equal to 7 because the 7 jumps the equal sign. The positive 1 jumps to equal sign, so I get x equals negative 1. So my intercepts, my x-intercepts, written as points, remember these are the points, 7, 0, negative 1, 0. And if I want the y-intercept, which is the last thing I'm going to give you, the y-intercept, we let x equal 0. So what that really means, you're evaluating the function at f of 0. And so you're plugging in zeros for every one of these values, for every one of these x's. So look, you plug in 0 here, that's just 0. Plug in 0 here, that's another 0. So you're left with just a negative 7. So this is the point 0, negative 7. And this is how you find all the elements to graph the actual quadratic.